Hello, fellow students. Today, as you've seen in the title, we're going to talk about alkanes, the simplest carbon group. Alkanes are compounds composed of hydrocarbons, a mix of carbons, and hydrogen atoms. They can also be called paraffins or saturated hydrocarbons because of the hydrogen and carbon atoms being linked exclusively by single bonds. They belong to a homologous series of organic compounds in which the members differ by a constant molecular mass of 14, having the general formula of CnH2n plus 2. Alkanes can have from a single carbon to a chain of thousands or even millions of carbons. The three simple carbon groups are alkanes, alkenes, and alkynes, which are defined by the presence of different bonds between the carbon atoms. Alkanes having only single bonds between the carbons, alkenes having the presence of at least one double bond, and alkynes having at least one triple bond. There are three types of structures on how to present a carbon chain: the condensed structure, line bond structure, and the skeletal structure. The skeletal structure is only composed of lines with each edge representing a hydrocarbon. These three are the most commonly used to demonstrate a compound. Before using the identifier for alkane, the suffix "ane", a prefix is used depending on the number of carbons. The simplest alkane, containing only a single carbon and 4 hydrogen atoms, is methane. The corresponding prefixes used for 1 up to 10 carbons are as follows: meth for 1, eth for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. There are also rules in determining how to name alkanes. The main group of alkane is the longest carbon chain available in the group of carbons. After that, identify the number and use the appropriate prefix of the formula. This is a pentane. As you can see, it contains 5 carbons in the chain. But what if I remove the final carbon and place it over here? The previously mentioned rule applies and certain measures are used before finding out the chain's new name. First, we should find the longest carbon chain, which consists of 4 carbons. As for the extra carbon that I moved earlier, it is now called a substituent, which is a small group of carbon attached to the main carbon group. This chain's new name is now 2-methylbutane. The substituent suffix is changed to -il, and the number depends on which carbon the substituent is attached to, which in this situation is carbon number 2. There can also be multiple substituents at a time in a given carbon chain. Another rule in naming alkanes is applied in how to write the substituents. According to the rule, the substituents are added according to alphabetical order. For example, there are 4 substituents in a given carbon chain: butyl, propyl, ethyl, and methyl. When the rule is applied, the order of the substituents is butyl, next is ethyl, then methyl, and last is propyl. Going back to alkanes, because there are constituents, there is a rule that the number of carbons in which the substituent connected must be as low as possible. Like this example. This can also be named as 3-methylbutane when you begin to count at the right. But because we should use lower numbering, the more appropriate name for this is 2-methylbutane. What if we move this substituent here? What will be the name of this one? Is this 3-methylbutane? The answer for that is no. It's still 2-methylbutane. You can begin counting at either side, the left or the right, but the correct side at which you should count first is determined by the lower numbering of the substituents. Alkanes have yet another form, the cycloalkanes. Cycloalkanes are a subfamily of alkanes. They have the molecular formula CnH2n. Cycloalkanes are alkanes that have its carbon chains first and final carbons connected. If alkanes have ends, cycloalkanes have no ends. They are all connected. Writing names is exactly the same, except that you only need to join a cyclo in the prefix, just like this example. The name of this compound is cyclopropane. This is the simplest cycloalkane compound because it has enough carbons to form a polygon. There is no cyclomethane and or cycloethane. As for the substituents, it is the same. Let's create carbon here. So, there it is. We now have a substituent. Maybe you are confused right now because you can see a propane and a cyclopropane in the picture. But a cycloalkane compound has a higher priority than that of an alkane compound. So, the name of our example is 1-methyl-cyclopropane. Proper numbering should always be observed, don't forget that. The first four alkanes are used for heating, cooking, and electricity generation. The main components are methane and ethane. Propane and butane are used as LPG, or liquefied petroleum gas. Propane is also used in the propane gas burner. Butane in disposable cigarette lighters. They are also used as propellants in aerosol sprays. Alkanes from having carbons 9 to 16 from the major part of diesel and aviation fuel, and alkanes from 17 carbons and upwards from the most important components of fuel oil and lubricating oil, also used as anti-corrosive agents, and as their hydrophobic nature means water cannot reach the metal surface. Many solid alkanes find use as paraffin wax also. Alkanes with 35 or more carbon atoms are used for road surfacing. Synthetic polymers such as polyethylene, oh shit, ay, huwag yun. Polyethylene.
Hello guys, it's me again. If you want to find out more about the basics of chemistry, then check out our channel. Also, don't forget to leave a like and subscribe. Have any remarks? Then drop a comment in the comment section below.